Today we're going to start going over the bones of the axial skeleton. Now I'm going to use our classroom model here to kind of go over each of the bones and talk about them and give their names. But it might be a good idea to take your book out and follow along as far as the names go so you can see them written. At the end I'll go through a summary so I can write them out and you can see how things are spelled. That's kind of up to you whether you want to use your book or not, but it might be helpful to go through that. Now, the skull has a whole lot of bones. We have the cranium on top and then we have the face. There's lots of bones there. It'd be a little bit hard to see on a video, so we're going to leave that part until I'm back and we can kind of talk about it and show it in class. So we're going to focus on the other parts of the axial skeleton, which include the vertebral column, your ribs, and that's pretty much it. The hips and the arms and legs, basically the pieces, I like to think of it as the pieces that you can get cut off and still be alive. Those are part of the appendicular skeleton, and we'll be covering those in a whole nother unit. So get your notes out and we'll take a look at the first few bones here. We're going to be going through 51 bones today, on our way to 206 total bones in the human body. Skull there's a lot of bones there. I mean, it looks like one big thing, but there's a whole bunch of bones, like 22 or something like that, bones that are going to be in the skull. So we're going to cover that later when I'm back. So today we're going to cover the rest of the axial skeleton and look at the ribs and the spinal column mostly. So we're going to turn the skeleton around here so we can kind of see the back of him. Okay. And you can see, as far as the shape of the vertebrae, so the spinal column is made up of a bunch of vertebrae, and the shape of them is going to change slightly as you go down. Now we divide the vertebra up into three main sections. So the top 7 are called the cervical vertebra. The next 12 are called the thoracics, and then the last 5 are called the lumbar. So you have cervical, thoracic, and then lumbar. And those are going to curve in specific ways. And the curve of them is important to keep your body weight kind of over your legs. If there was no curve to your spine, your body weight would be farther back and you'd kind of be on your heels all the time. So that curve is actually important for shifting your body weight in a way that is going to make you more stable as you're standing. Now, when we talk about the vertebra, we tend to just give them numbers based on their position. So the cervical vertebra, there's 7 of them, so we would label these as C1, C2, C3, C4, all the way down to C7. So if you hear about somebody breaking a C7 vertebra, that means they're breaking kind of the bottom part of what we would consider the neck, right above where the shoulders are. Now, there is a couple caveats there. The top 2 vertebra, cervical vertebra, have specific names to them. So the top one is called the atlas because the head kind of rests on it, so it's named after the Greek titan who held up the earth. The one underneath that is called the axis because that's where a lot of the turning of the head takes place, and it's the combination of how the atlas and the axis go together, C1 and C2, that allows the head to pivot as much as it does. Okay, your 12 thoracic vertebrae are going to be the ones that are associated with your rib cage. So we'll talk about the ribs in a minute, but the ribs wrap all the way around the back and they're going to be connected in the back to your spinal column, to those vertebrae. And so we call those the thoracic ones, and we label them out like that specifically because they are going to be connected to the ribs. There's no special names there, we just name them from top to bottom, T1 through T12. Okay, and then finally on the bottom we have 5 lumbar vertebrae, and those are going to be the ones that are going to hold up a lot of the weight of your upper body. So if we take a look here, here's a cervical vertebra. You can see it's fairly small and delicate. It's made so that it will pivot. Here's a thoracic vertebra. Much bigger. It's got more bone and more padding right there. And then we have a lumbar vertebra. And you can see here, this one is much sturdier. It has to be to hold up all of that weight. You know, all of that weight is kind of compounded on top of it, and it's going to have a lot more padding in between as far as the cartilage goes as well. Okay, now the functions of the vertebra are going to be obviously to, you know, hold up your upper body, but they also protect your spinal cord. And so their structure is going to kind of show that. If you look at these two lumbar vertebrae here, you can see those. They've got these ridges that stick out from the outside, and when they go together, those kind of lock together. And that makes them so that they can't really turn that much. There's a little bit of pivoting, so when you pivot, they will turn just a little bit, but they're pretty much locked in place so that they can't turn very much. Compared to the cervical vertebra up on the top, where your neck pivots, okay, those don't have near the interlocking, oops, put these together the right way, those don't have near the interlocking that the lumbar vertebra do. They're still going to interlock a little bit. So the fact that your neck can pivot so much has to do with each one of those articulations where they meet up turning a little bit. So this one will turn a little bit, the one on top will turn a little bit, the one on the bottom will turn a little bit, and you get much more movement like that. But they can move a lot more than the lumbar vertebra. The other thing that we should see is the big gap in between, and that's where, of course, your spinal cord is actually going to run. So when this thing is put together, like on the skeleton, we see there's a hole, and here he's got a pull through there to keep him together. But that pull is going to be where the spinal cord would actually run to carry all your nerve endings down to your bottoms. And so if you break your back, that's going to sometimes sever that spinal cord, and it'll cut off all of those feelings and nerve endings, and more importantly, muscle control down in the bottom. It'd be one thing if you couldn't feel your legs, but the muscle control that has to come from your brain to tell your legs to actually move, that's the more important thing. That's going to mean that you may spend the rest of your life in a wheelchair. Below the fifth lumbar vertebra is the sacrum, and so it's a big fused bone. It looks like, if you kind of look at it, it almost looks like a bunch of vertebrae that were fused together. It's going to carry a lot of the weight and spread it out to the hip bones that we'll be talking about later, like the ilium and the ischium and the pubis. So it's going to connect the hip bones to that vertebral column and spread the weight from your upper body down through your hips and to your legs. Okay, now the sacrum has kind of a hole in the back of it that starts right here, so this would be the back end. It goes through here and comes out here, and that's where a lot of the nerves that go down to your legs end up running through, because of course this is sitting right below the spinal cord. And so as the spinal cord runs down, there's a lot of nerves that branch off, sensory nerves and motor neurons, that are going to go out to different parts of the body, but the ones that go down through your lower part have to kind of branch off down through here and then come out to go to your legs and things like that. So that's a major nerve network right through the sacrum. Now below the sacrum is the little tailbone. The name for the tailbone is the coccyx. The tailbone doesn't really have a function. It's kind of a leftover thing. It's a vestigial structure, something that harkens back to our evolutionary ancestors. But it is a bone, and you can break it. It is painful. It makes it hard to sit down. But other than that, it's just on the end of the sacrum. Okay, let's move to the front of the axial skeleton. So here we have the ribs, what's also called the thoracic cage. And the ribs are nice and easy because we just basically number them, starting at the top. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 ribs on each side for a total of 24. Despite what you may have heard, men and women do not have different numbers of ribs. Same number. I don't know why that rumor persists. I'm sure it harkens to the biblical story, but all you have to do is look at somebody's dead body and count to know that all humans have 24 ribs. Now we do split the ribs up a little bit. So the first 7 on each side are called true ribs because each of those connect through a little piece of cartilage to the sternum in the middle. So because they connect that way, we call them true ribs, whereas the other are called false ribs because they either connect like these do to another piece of rib, one of the true ribs, or these ones down here, if you can see, are not connected at all. And so these are both called false ribs along with the other ones, and they're also called floating ribs because they don't actually aren't actually connected to anything. They just kind of stick out like that. Of course, the function of the rib cage is to protect most of your internal organs. Not so much your stomach and gastrointestinal stuff, but of course that's not near as important as like your liver and your heart and your lungs all contained. But it's very important that we have cartilage here. If these were solid bone-on-bone connections, what we call articulations, then your rib cage, your thoracic cavity, wouldn't be able to expand and contract during breathing, and you wouldn't be able to breathe, or at least you wouldn't be able to breathe near as well. So the fact that this is, I mean, it's still protection, but it's a flexible protection is important. And so then the last bone that we're going to talk about, of course, is this big one in the middle called the sternum. There's different parts of the sternum. We're not going to really focus on that, but of course the one that you hear about a lot of times is the xiphoid process right here, because that's where you're supposed to kind of landmark off of when you're going to give chest compressions for CPR. So that's the main parts of the axial skeleton. The vertebral column, sacrum, coccyx, and then the rib cage and the sternum. So let's summarize the bones of the axial skeleton that we've learned so far. So to start with, we have the 7 cervical vertebrae. Then we have the 12 thoracic. And then we have the 5 lumbar, for a total of 24 vertebrae. Then you have 1 sacrum, 1 coccyx, and that kind of makes up your overall, I don't know, base of the axial skeleton. So that gets us up to 26 bones. Okay, then in the front we have 14 true ribs. We have 10 false ribs. And of course, 4 of those are what we call floating. And then we have 1 sternum. So 26 plus 14 is 40, 50, 51 bones so far out of 206 in the entire body. So those aren't too bad. I mean, most of the bones in that part of the axial skeleton really just get numbers to them as far as like the vertebrae and the ribs. So that's a lot of bones that we can get out of the way and be able to name fairly easily. Next week we'll take a look at the skull, the cranium, and the face. There's a lot of bones there, and they all have names, some of which make sense, some of which are just weird names you have to learn. So that's going to take a little bit more to go through. But once we've done that, then we'll go through and take a test on the axial skeleton before we move on to the appendicular skeleton. I would suggest as we go through these different bones, when we're done, it might be a good idea to come up, take a look at the skeleton, because we're going to have a practical test on these where you're going to have numbers on the skeleton. In fact, you can see some of the ones that I had on there last year. And you're going to have to be able to name those bones. So it would be a good idea to get some practical experience with looking at them and where they are on the skeleton.